In this video, we're going to be taking a look at a 2D collision problem where we have a blue car that is 800 kilograms traveling directly to the right at 6 meters per second, and we have a 500 kilogram car going 12 meters per second upwards. Now, because we have things moving in the X and Y direction, it does complicate things a bit, but since there's only one thing in each direction and they are perfectly along the X and Y axis, it does simplify things too. So we're going to find the final momentum, the direction, and the final velocity for a perfectly inelastic collision. Now, the key is perfectly inelastic, which means the two do kind of stick together and travel as one big mass after they collide, and then some kinetic energy is going to be lost in the process, but we're not really focusing on that part right now. Now, what we can do is go ahead and find the momentum for each of these, which is pretty simple. We're going to go ahead and do m times v and do m times v for the red car as well. Okay, and both of those units are in kilogram meters per second. So I'm going to go ahead and put those in with my momentum values because we have masses in kilograms and velocities in meters per second. So basically just those two units combined. Now, as I said earlier, we have two types of momentum going along each of the axes, but they're perfectly in the horizontal and vertical direction, which does simplify things quite a bit. So in the end, we're going to have something that is moving in this direction. Now, we don't know exactly at what angle, but if this one's going up and this one's going to the right, it's going to be going up and to the right in some form. Now, we have 4,800 kilogram meters per second to the right, and then 6,000 going upwards. So we're going to have a little bit of a larger vertical component. So what we can do is do some vector addition and take our horizontal component of 4,800 and then use the tip to tail method with our red vector and put that up at 6,000. And then if we combine those two, we can find the resultant vector. That resultant vector is going to be our final momentum for both of the cars after the inelastic collision. So we're going to go ahead and find the final momentum, the velocity, and then the angle.
Avant, tu voyais que de la merde. Maintenant, au moins, tu vois plus rien.
All right, so we just used the Pythagorean theorem and just took our two momenta, 4,800, and then squared it, and we added it to the 6,000 squared. So a squared plus b squared equals c squared, and then square rooted both sides to find our resultant momentum of 7,683.75. And again, that's in kilogram meters per second, which I didn't wedge that into there. I'll just go ahead and write it off to the side over here because I was being too lazy to write that big unit in. But that's our PF, our final momentum or resultant momentum with both of those combined. Now, the second thing I did is in purple, we have that final momentum equal to a total mass of 1,300. I just added the 800 and the 500, and that was a lot to do that because it was a perfectly inelastic collision, so those masses do combine. So we just have a simple momentum equals mass times velocity, divide both sides by 1,300, and then we have a velocity of 5.91 meters per second. As our final step, we're going to go ahead and find this theta value right here so we can get an exact direction. And for this theta value, we have the opposite and the adjacent end. So we want to use tangent. So we're going to go ahead and do the inverse tangent function of the opposite end divided by the adjacent end. and that's going to give us 51.34 degrees. Okay, if you want to be a little bit more specific, you can say that is north of east if you do use that kind of notation, because here's directly east, so it's tilted up north of east. So then you know exactly where that 51.34 degrees is. So that is the final part of our solution. So we have the final momentum check over here in green. We have the direction over here in orange, and then we have that final velocity in purple. So I hope that was helpful in helping you solve a 2D car crash that's perfectly inelastic. Thank you for watching and listening.